All right, let's discuss some of the questions from the note cards that people submitted in class today regarding material from chapters 1 through 3. So some of the questions are answered in a PDF. The others I thought could use some explanation. And so the first question that I wanted to explain was about finding how many protons, neutrons, and electrons we have when we have an element symbol. So the notation is X is the chemical that we're looking at with its symbol from the periodic table. Z is the number of protons, which we have at the top of the element on the periodic table. A is the mass number, so the number of neutrons plus the number of protons. And then the charge tells us the number of electrons, but first we have to do protons to figure out what this number would be. So we have to either add electrons if we have a negative charge, and we have to remove electrons if we have a positive charge. Okay? So what we're going to do then is let's look at an example. So let's say I was looking at, I need a periodic table. Zinc 66. And so also let's say it's the +2 ion. Okay, so what that would look like is zinc 66 goes up here and +2 goes down here. If you look at zinc on the periodic table, it's element number 30. So we have 30 protons. Then to find the neutrons, we take the mass number, which is 66, and subtract the 30 protons. So this gives us 36 for our neutrons. Now because it's a +2 charge, that means that we need to take the number of protons, which is 30, and we're going to remove that number of electrons. So we're going to remove 2, and we will have 28 electrons. Since we have more protons than electrons, we are going to have this +2 charge. And so that's how we know how many electrons something has, is it's based on the charge and the number of protons. The next major topic on the cards was naming. So a lot of folks asked for more practice with this. It also says, how do we name the two? We also asked, how do we know if something has both ionic and covalent compounds? And people wanted me to kind of go through the flow chart and give a tutorial on how that looks, and kind of helping you understand the difference between those. So when we're naming, we're always looking at two things. We're looking at the first element and the second element. So if the first element is a metal, then we know that we're going to have something ionic. If our first element is a nonmetal, then we're going to have something covalent, because our second element, regardless of ionic or covalent, will always be a nonmetal. Then we say, all right, well, what do we do if we have a polyatomic? Polyatomics will always be ionic compounds. And the deal with polyatomics is that these are the only ones that have covalent compounds or covalent bonds and an overall charge. And because they have both, they're still ionic, but they contain covalent bonds. Okay? Then the only other option that you might see, right, is you might see H in front, and those are our acids. So let's take a look at our flow chart. So the flow chart says, okay, what kinds of bonds do we have? that's always our first question, so we know how we're going to name. If we have a metal plus a nonmetal, or if that nonmetal is a polyatomic, then we know that the types of bonds are ionic bonds. So maybe I'll rewrite this a little bit nicer. So we know that there's only two types. There's only ionic and there's covalent. So ionic means metal plus something. That can be another atom, which is a nonmetal atom, or it can be a metal plus a polyatomic. If we have covalent, then we have two nonmetals, meaning we're looking at the right-hand side of the periodic table. So if it's ionic, we have to name the cation, which is our positive bit, and our anion. The cation is going to be a metal, so we're just going to name the metal. If it's 1A, 2A, or 3A. But if it's anything else, then it's a transition metal. And this is when we have to say what the charge is using our Roman numerals. So I means +1, II means +2, III means +3, IV means +4, V means +5, and VI is +6. Then we name the anion. So our anion is either going to be an atom, and we're going to give it the "ide" ending, or it's going to be a polyatomic. And you just name it as is. So name as is. So my biggest tip for you when you're doing any kind of naming is make sure you have this part, identifying the ionic or covalent, down pat first, because if you don't identify it correctly, you're going to have a really not fun time trying to name it because you're not going to be able to know which rules to apply. Okay, so here we've got two nonmetals. For covalent, we have to make sure we're naming it the right type. So that's pretty much it. And we also have the hydrates, so I'll put those here. The hydrates are when we do the dot, however many we have, H2O. Okay, so that's it for the ionic. Now let's talk about covalent. We have two types. We have acids or not acids. Just two atoms, okay? If we have two atoms, then we do prefix plus our atom, and then we do a prefix with our atom again, but this time we need the "ide" ending. And we ran out of space a little bit, so let's name acids down below. So we're still on the covalent side, but let's recap naming acids. We have two types of acids. We have acids where we just have H plus an element, and we have H where it's paired with a polyatomic. If it's H with an element, that's where we use our hydro prefix. Then you name your atom, and then you add the ic acid at the end. If it's H plus a polyatomic, then we do no on our word hydro. All we do is we take the name of the polyatomic. If that polyatomic ends with 8, so for example, nitrate, sulfate, phosphate, then the naming becomes ic acid. If we have an ite ion, nitrite, sulfite, phosphite, then it goes to us acid. So let's look at an example. Let's say that I have H2SO4, okay? What is this thing? Well, this is sulfate ion. I know I have H in front, so it's an acid. Sulfate gets its name changed to ic acid. So this is sulfic acid. The correct name is sulfuric acid, but I would accept either one because it demonstrates your knowledge of how you apply the naming rules. So we'll name this as sulfuric acid, although I would also accept sulfic acid. What about HNO3? This is a little bit more straightforward. NO3 is the nitrate ion. It becomes nitric acid. What if I name HNO2? This is nitrite. I'm going to take that ite ending, lop it off, and now it's nitrous acid. So those are the main things for naming. Somebody also asked, how do you name the different compounds, especially with more than two, and I assume they mean atoms. So again, a very important part of naming is that you should only be naming two atoms unless you're naming a metal, right, plus a polyatomic, in which case you don't have to name all the atoms because you're naming the entire polyatomic. If there are more than two elements, and you're saying it's not a polyatomic, then I am not going to ask you to name that. So if you think that I made a mistake, I will probably remind you that I'm never asking you to name more than two elements unless one is a polyatomic, in which case I would have you review that chart. Somebody asked me about naming elements that have several ions. So let's look at a couple more examples. So let's say we wanted to name FeCN2 versus FeCN3, which you did in your check-in from Friday. So here we know that Cn is a -1 ion. So in order for this compound to be neutral, this first one, we know that the iron has to have a charge of +2 because we get -2 on this side. So we will name this as iron with the 2 in parentheses, and then we name our polyatomic. Whereas on this side, because Cn is -3, but we have 3 of them, the iron has to have a charge of +3, so this one is iron 3 cyanide. So again, we only need the Roman numerals when we have a transition metal. So the Roman numerals tell us the charge of the metal, and we only use it for transition metals. And the last question on the study sheet, so question 3, of the note cards that people had, was the difference between a formula mass versus a molar mass. There's really no difference. These are the same. So formula mass is for the formula as written, but so is the molar mass. So we will use these two ideas interchangeably throughout the semester.